The regression line of y on x can be written as y minus y bar is equal to b subscript yx into x minus x bar. But how? First, we will take regression line y on x as y hat is equal to a plus b subscript yx into x. The residuals for y on x line will be written as y minus y hat or y minus a minus b subscript yx into x. Using the least squares method, one of the normal equations obtained is the summation of residuals is equal to 0. Now we can substitute the formula for y hat and equation will look like as shown on screen. Then we will apply summation to each term and will get summation yi minus na minus b subscript yx into summation of x is equal to 0. After that we will divide this equation by n and then using means we will get y bar minus a minus b subscript yx into x bar is equal to 0. Then we will solve for intercept and get a is equal to y bar minus b subscript yx into x bar. After substituting this into original equation and simplifying, we will get y minus y bar is equal to b subscript yx into x minus x bar. In this centered form, the intercept disappears and deviations are explained by the slope only. This form of the regression equation clearly shows an important property. If we substitute x is equal to x bar, then we can see from the screen that the right hand side becomes 0, which results into y hat is equal to y bar, which means the regression line passes through the point x bar, y bar. Hence, every regression line must pass through the mean point of the data. By applying the same steps to the regression of x on y, we can similarly show that the regression line of x on y also passes through the mean point x bar y bar. Thus, we can say that the intersection of regression lines y on x and x on y takes place at the mean points of x and y. This shows that the regression explains deviations from the mean and therefore mean point becomes the fixed reference point of the regression line. In the next video, we will study the relationship between slopes of regression lines and correlation between x and y.